Okay, for this video, we'll be discussing the May-June 2025 paper 6.5 for probability and statistics 2. Let's have a look for question number 1. We have a random variable x with the Poisson distributed with the lambda 1.5. The sum of the three independent values of x is denoted by the s. So highlight the keyword sum. Sum means the addition, right? And s will be the sum of 3x. Find the probability that s is smaller equals to 3. So first of all, you need to know that s can be written as the sum of 3x. So I'm having x1 plus x2 plus x3. And when you are trying to get the mean of the s, basically you're having mean of x plus mean of x plus mean of x. And what is the value for the mean? 1.5 plus 1.5 plus 1.5. Okay, therefore you get 4.5 here. Right? Yeah. So for the variable of x, s basically you need to have the new lambda for the s. Yeah? Alright, so from here you know that it is 4.5. All the x are Poisson distributed, therefore the linear combination of Poisson is also Poisson distributed where the lambda is 4.5. Okay? Alright. Then after that, let us have a look for the probability. How to calculate the probability for s smaller equals to 3. Alright, then again, the general formula is like this. Yeah? If you're having the sx with the Poisson with a mean lambda, okay, to calculate the probability for x equals to r, the general formula is e power negative lambda, lambda power r divided by r factorial. And the r here should be all the positive integer. Okay, then after that, usually for me, if the question asking me to find out x smaller equals to r, right, I prefer to group and factorize out the e negative lambda in front. And this formula, basically, it will be something like this. When you factorize the e power negative lambda, the first term is having lambda power 0 divided by 0 factorial when x equals to 0. So lambda power 0 divided by 0 factorial. And this value is always equals to the 1. Okay, then the next one will be x equals to 1. You're having lambda power 1 divided by 1 factorial. Then you should be having the lambda. Okay, then for x equals to 2, you're having lambda squared over 2 factorial. X equals to 3 will be lambda power 3 divided by 3 factorial. And then until you continue the value of the x 1 by 1 until you get lambda power r divided by r factorial. In my opinion, when you try to write out in this form, it will be easier for you to press the calculator and get the answer. Alright, it will reduce your chance of making maybe careless mistake, right? Okay, then let's continue for our calculation part here. S smaller equals to 3. I'm having e negative lambda. When x equals to 0, it is 1. When s equals to 1, it is lambda, which is 4.5. When x equals to 2, it will be 4.5 squared over 2 factorial. For x equals to 3, you'll be having 4.53 divided by 3 factorial. And our calculation here should include the s up to 3. So that means including the 3. Alright. Yeah, so you should stop here. Then again, press calculator and you will get an answer, longer answer from the calculator. Then of course, don't forget to cut it short into 3 significant figures as the final answer. And by right, you should be having 0.342 correct to 3 significant figure. This is what we have for part A. Then let's continue to part B. They want us to show that the exact value of this is this answer. Okay? Right, so let's start with the probability first. Yeah? S smaller equals to 2 divided by S smaller equals to 1. What is the formula for S smaller equals to 2? I'm having E negative lambda, then lambda power, small equals to 2, right? So that means you have to start from x equals to 0 as well. So s equals to 0, you're having a 1. S equals to 1, you're having 4.5, which is the lambda. S equals to 2 will be 4.5 squared over 2 factorial. Then divided by the probability of E smaller equals to 1, I'm having E negative lambda also. When s equals to 0, it is a 1. When s equals to 2, it is 4.5. When s equals to 1, it is 4.5. Just now I should say s equals to 0 is 1, right? Then s equals to 1 is a 4.5, which is a lambda. So I shouldn't include s equals to 2 here because they want us to find out the probability until s equals to 1 only. Okay, after that, I think it's quite straightforward. You can just directly simplify the e power negative 4.5. Then try to simplify the numerator. The value that you get is a fraction, which is 125 over 8. Then what's a fraction at the denominator? If you multiply them together, if you add them together, you'll be having 11 over 2. Then simplify it, you'll be having 125 over 44. Right, yeah, so this is how we get the answer for question number 2. We are given a random sample of 200 values of a random variable x. Then there are some summarize of the data. Okay, so we are having n equals to 200. Summation of x minus 2 is equals to 60. Summation of x minus 2 squared is 20. So find a 95% confidence interval for the population mean of x. Alright, maybe before that I want to show you the formula for confidence interval first. Okay, to get the confidence interval for mean, the general formula is you have to take a sample mean minus z population standard deviation over square root n. Simply happen here, you need to have sample mean plus z, then sigma population standard deviation over square root n. Okay, so for sample mean, I think should be no problem for us to find out because we are having the summation of x minus 2. But compare with maybe the previous question that we tried, right? They always give us summation of x, no negative 2, right? But for this year, they give us the value where you are having summation of x minus 2. And what is the formula of the mean if you want to get value of mean by using summation of x minus 2? I don't know whether you still remember there's one formula in coding method or not for our AS stats 1. That's a general formula where if you are given summation of x minus a, to find the mean you have to divide it by n, then you have to add back the a so that you can get back the original mean of the x. So this formula basically we apply in coding method in stats 1, I think, chapter 1 in stats 1. So if you already forget, then maybe you have to recall a little bit. Right. Then after that, if you have a look for the confidence interval for mu, right, z can be found easily and also is given in the question. And how can I get the sigma here? The sigma here means the population standard deviation. We are given a sample. How can I use the sample to estimate the population standard deviation? Okay, therefore you have to use the unbiased estimated variance formula. Unbiased estimated variance. What's the formula for unbiased estimated variance? Yeah, the original formula is like this. 1 over n minus 1. Okay, and we are having summation of x squared minus summation of x squared then divided by n. This is the original formula for unbiased estimated variance. Okay, but if you have a look for our question here, we don't have summation of x squared, we don't have summation of x, but we are having summation of x minus 2 and also summation of x minus 2 squared. Okay, then how can I replace the information that we have in the formula? So what you need to do is like you just need to change the x become x minus a. Alright, so for this one, let's say this one, I try to expand it a bit. Okay, then when I write it out, originally it is x squared, right? Then I just want to change it become x minus a squared. Then simply happen for the summation of the x. What you need to do is you have to change it become summation of x minus a then squared. Alright, then maybe some of you will ask why I just directly change the formula become x minus a will be still getting the same answer for the variance or the estimated variance. Right, the reason is because of when you are trying to minus 2 for every single value of the x, right? Basically, the original shape of the x is still the same. The spreadness is still the same. Therefore, for any formula that involve the variance or standard deviation, if you want to use the coding method, the formula basically is still the same, just that you need to modify it from x squared become x minus a squared. Then simply happen here, summation of x, you modify become the summation of x minus a, right? Because basically the spreadness, the shape of the data is still remain the same, although you already minus every single value of x by using a or by using 2 in this case, right? Okay, then now let us start the calculation part. First, I want to calculate the sample mean. So to get a sample mean, you are having 60 divided by 200, then plus a. A is a 2 in this case. Alright, then we are having 2.3. That's my mean. After that, I want to get the unbiased estimated standard deviation. Unbiased estimated, maybe I put variance first. Then later in the calculation for confidence interval, only I change it becomes standard deviation. Okay, so for this case, I will be having 1 over n minus 1, which is 199, summation of x minus a squared, which is 20, minus summation of x minus a, which is 60, then square, divided by n, which is 200. Okay, then again, simplify your value by using calculator. It will give you a value which is 2 over 199. I will keep it in the exact value, right? Because I want to use it in the calculation for confidence interval later. Okay, I already get the sample mean. I already get the unbiased estimated variance. Then next one, I need to get the value of the z. How to get the value of the z? For this question, they are requested for 95% confidence interval. And for 95% confidence interval, where is your z? 95% means that the center part, 95%, so it will be 0.95. So that means when the graph is symmetrical, right, in a normal distribution, this area should be 0.025, this area will be 0.025, and the value of the z basically refer to this one. How can I get the value of the z? You need to find out the area from the normal distribution in a reverse way. So the area that I'm referring to is the whole area here, the red color area, 0.975. Go to the table, scroll down to the shortcut table, looking for 0.975 for the p, which is the area of probability. So 0.975, the value of z that give is 1.96. So from here, I know that my z is 1.96. Okay, then you can see that I already got everything ready for the confidence interval for mu. Then we can start the calculation. 95% confidence interval for the mu. What is it? Okay, so just put in all the value that you have. Mean minus z, then sigma over square root n. I don't have sigma, but I have variance. So I take 2 over 199 over n. Then I take the square root for the whole thing. Same thing happen for the upper limit. Okay, so this one is a common. Square root of 2 over 199 divided by 200. Okay, then from here, what do I get? You'll get a very long answer. Okay, then cut it short into 3 significant figures. By right, your answer will be something like this. It will be 2.29 and also 2.31, correct to 3 significant figures. Alright, yeah, so this is how we get the answer for 2A. Then let's continue to discuss part B. They are asking, state in which part of the solution in part A make the use of central limit theorem. Okay, so like what we know earlier, right? When are we going to apply central limit theorem? We apply it when we don't know the distribution of population. From here, they didn't mention anything about the distribution of population, right? Totally, you don't see any keyword. All right. So that means we are using central limit theorem to calculate the confidence interval because we are using the Z. Do you see the Z here? You can see that from here we are using normal distribution to get the confidence interval. That means we are using the central limit theorem here because we actually don't know the population distribution, and we are using the normal distribution to calculate the confidence interval. That means we are using central limit theorem. All right. Okay. So in which part they are saying? Then you can say that we are using the normal distribution to find the confidence interval. This already means that we are using the central limit theorem interval. Then maybe if you want it to be more precise, then you can just tell them that we find the value of Z. And from here, you already know that Z is normal distribution, right? Normally distributed. Okay? Yeah, so this is how we solve. Question number 3. Morola's calculator can generate random number between 0.000 and also 0.999 inclusive. Okay, and please take note that the random numbers that being generated is up to 3 decimal places. So you can see here, right, 0.000 until 999 is 3 decimal places, yeah. Correct to 3 significant figure. Oh, okay. Then she plans to use her calculator to choose a sample of members from the 851 members in her health club. She numbers the member from 1 to 851. Then she used her calculator to generate some random number. She multiplied the random number by 851 and round up to the next whole number to give the number of member in the sample. This is called a member number. All right. So you need to understand what is the process here first, yeah? Basically, when she want to select the member, she will need to select it using the member number. But how to generate the member number? What she do is like she create the random number first. She create a random number first. After that, she multiply the random number with 851. Multiply. Then after that, round up. After she round up the number that she get, then only the member will obtain the member number. So this is basically the process that you need to know, right? And how she get the random number, it is from the calculator, because the calculator can generate this number, right? Correct to 3 significant figure. So they take the random number, multiply with 851, round up to the next whole number, then to get the final member number here. So that's the process for her to decide the member number, right? Okay, then let's talk about round up. What's the meaning of round up? Okay, round up means that when you're having any decimal number, as an example, if let's say I'm having 78.012, let's say, then when you want to round up, it will become the next whole number, which is 79. Although the 78.012 is closer to 778, right? But round up means that you are going to make it into the next bigger integer. So 78.012 will make it become 79. Even if we have 78.912, then again, if you try to round it up, it is also 79, right? So please make sure that you are aware of the meaning of round up first. Alright, so here they give you one example. If let's say her first random number is 0.401, find the member number that is produced by this random number. Okay, so first of all, we are having the random number, right? 0.401. This is a random number. You multiply it with 851. So what's the next value that you get? You will get 341.251. You press calculator and you get this value. But of course, this one cannot be member number. You have to round it up. So when you want to round it up, 341.2 something, if you round it up, it will become 342. Okay, so this is basically the member number that you get from 0.401. So you can write out like this. The member number is 342. Okay, yeah. So you just need to make sure that you understand the process, right, to get the member number. Then it will be quite straightforward, right? Okay, after that, let's have a look for part number B. B part 1. Find all the possible random number correct to 3 decimal places that would produce the following member numbers. So now, in part A, they give you random number, they ask you what is the member number. But now for part B, they give you member number, you want to figure out what is the random number. Okay, that means to find the random number, have to do it the other way around, correct or not? So, which means that you have to take 680, divide by 851, and see what do you get. Okay, so let's take the first one, 680 divided by 851. And let's see what do we get here. 680 divided by 851. You'll get the value 0.799. Okay, you'll get the value for 0.799, which means that if you take 0.799 multiply with 851, then you need to round it up into 680. Okay, so that's one of the possible value. And then I will want to try and figure out, if let's say I take 679 divided by 851, what do I get? So you take 679 divided by 851, then I get 0.798. Right? Then I double check back the answer. Okay, so this one, if I take 0.799 multiply with 851, I'll get 679.949. Okay, which means that I will round it up, become 680. This is correct. Okay, then let's have a look. If let's say I'm having 0.798 multiply with 851, what do I get here? I'll get the value 679.098, where if I round it up to the next value, it will be 680 as well. Okay, yeah, so you can see that actually these two random number will give you the final answer of the member number 680. If you feel like not so sure, right, you can try error again for 678. Okay, then you take 678 divided by 851. What do I get here is 0.797. Then if you try to double check, 0.797 multiply with 851. What do you get? So you have 678 point something. Okay, therefore when you try to round it up, it will be 679. So this is not the answer that I want, right? And then these two are the answer that I want. Correct or not? Okay, so maybe you ask how I know that I need to try one number smaller than 680, okay, to check whether do I get the member number 680 or not. The reason is because of the value that we get here should be a long value, but we cut it short, correct, to 3 decimal places. So when you multiply the 3 decimal places answer with the 851, you might get back the round up integer, which is 680. Therefore, I try to test the try and error. Basically, I'm using try and error method. I start from 680, then followed by 679. Then actually, I did try out 681 as well. Okay, because for 681 divided by 851, then you get 0.8. But if I take 0.800 multiply with 851, then the number will be 681. So that one is not belongs to our answer already. For me personally, I try an error to make sure that I didn't miss out any possible value. Okay, all right, so I need to try error because of there's a simplify here. Okay, when you get the answer here, you should get a very long answer because of you try to cut it short into 3 decimal places, then they might appear some numbers where after you round it off or maybe after you simplify it and multiply back the 851, it will give you the final member number as 680. Right, so from here, the answer for the random number, okay, or maybe you can just write out the random number first. The random number that will give you member number 680 is 0.798 and also 0.799. Okay, then let's continue further for part 2. A member number of 850. So the same thing happened here. I try 850 divided by 851. What do I get from here? 850 divided by 851. And I get 0.999. Okay, then I double check back. Okay, I use 0.999 multiply with 851 and see what do I get. Okay, so I'm getting 850.149. That means this is 851, right? This is not the answer that I want because I'm looking for 850. Then I try to check the number previous, the previous number, 849 divided by 851. I got 0.998. Okay, then I take 0.998 multiply with 851. Then you'll get 849.298 where you try to round it up. So when you round it up, it will become 850. So this is the answer that I want. Then if you are not so sure, then you just double check a few more numbers. Okay, by right, the 848 will not give you the integer 850 anymore. It will give you the integer 849. Then if you feel not safe, then you try 851 also. 851 divided by 851, you get a 1, which is impossible, right? Because the maximum number that they can, the calculator can generate is up to 0.999. And 0.998 will give you 850, but 0.999 won't give you 850. Okay, then like what I told you, if let's say you're not feeling not so safe, then you try one more number below, 848. Then by right, you shouldn't get the answer as well, right? Okay, so from here, you can see that there's only one random number for the member number of 850, which is 0.998. Okay, yeah, so this is how we get the answer for 1 and 2 for part B. Then let's have a look for part C. Now they want you to explain briefly how your answer to part B show Marola's method does not produce a random sample. Okay, when she want to select a random sample from member, right, she depends on the member number. But according to what we calculate just now, you can see that for a member number of 680, it will be having a higher chance from the random number to be created, the 680, right? Then but for 850, you have only one random number that will create 850. So that means you can see from here that it is not a fair random sample because the probability of being selected is not the same. Okay, so this is your conclusion. Now you can make the reason why. So you can just tell them that there's a higher chance to get certain member number. So for our example here, basically it is 680 because 680 will have two random number to get 680. All right, then the other number, then the other member number, which is basically 850. Okay, or you can just tell them that the probability of obtain each member number are not equally likely also can. Or you can just tell them that the probability okay, of obtaining each member number are not equal. Okay, so as long as sum is higher for the probability sum is lower, then basically that's not a good method to produce a random sample. Alright, so this is how we solve question. Question number 4. We are having the number of cars and also the truck arriving per minute. Okay, with distribution Poisson, lambda 0.8 and also Poisson with lambda 0.5. Then find the probability that at least 4 cars and also at least 2 trucks arrive at the fuel station during a randomly chosen 5-minute period. Okay, so for this question, we are having Poisson distribution and we are having 2 types of vehicle. We are having car and also the truck. And the lambda given here is for 1 minute, 1 per minute. You can see from here, right? Per minute. And now when they want us to calculate the probability, we are interested for the 5-minute period. Therefore, we have to change the lambda first before we can find out. Okay, so let's have a look for the car. Car is Poisson distributed. 1 minute is 0.8. Therefore, we have to make it become a 5-minute period one. So 1 minute is 0.8. So 5 minutes have to take 0.8 multiplied with 5. Agree? Then what do you have here? You will be having the 4. Okay. Then after that, for the truck, I put it as a T. It is also Poisson distributed. The lambda for truck is 0.5 per minute, and I'm having 5 minutes now, therefore I have to multiply with 5. And from here, I'll get the new lambda 2.5. And for this question, they are asking for the probability of at least 4 cars. So car greater equals to 4. And so intersect at least 2 trucks. So T greater equals to 2. And to calculate this probability, because they have mentioned clearly that this they are modeled by independent variable, right? So highlight the keyword independent. When you're having independent events, to find out the intersection part, you can just directly multiply them. Because for independent cases, just to recall back, this is a little bit related to the AS stats 1, right? So when you're having A and B independent, then A intersect B can be written as probability of A multiplied with the probability of B. A and B independent. Let's say you're having the event where A and B are independent, then these 2 events, when you multiply the probability, you'll get the value same as the intersection of the 2 events here. So I'm going to apply this also here. I know that C greater equals to 4 multiply with T greater equals to 2. Okay, then let's continue from here. How to calculate the probability for C greater equals to 4? Okay, so for Poisson distribution, you need to start from 4, right? Then 4, 5, 6, 7, 8, 9, 10 until infinity, which is quite impossible. So we are using 1 minus. So I want to use 1 minus the probability of number of car less than 4. For the T also the same, I want to use 1 minus the number of truck less than 2. Okay, because the number of car and number of truck can go up to infinity, which is impossible for us to get the value. So you have to use 1 minus, right? Okay, then 1 minus car smaller than 4 means I have to include C equals to 0, C equals to 1, C equals to 2, C equals to 3. So let's start E negative lambda. The lambda for the C is a 4, right? Then the first term is always a 1, second term is always a 4, third term is 4 square divided by 2 factorial. Then next term will be 4 power 3 divided by 3 factorial. This one basically means that C equals to 0, C equals to 1, C equals to 2, C equals to 3. So I have to take 0 until 3, right? 4 shouldn't be included. C is smaller than 4 means 4 shouldn't be included. So there's no 4 here, right? 4 power 4, no. Okay. After that, I have to multiply with 1 minus T smaller than 2. It will be E negative lambda. When T equals to 0, you're having a 1. When T equals to 1, you're having the lambda, which is 2.5. Should you include T equals to 2? No, right? Yeah, so for the number of trucks, this is the probability that I have. then you need to be a little bit more carefully. Try to press calculator and get the value. Alright, so the two value that you get should be something like this. You double check and see. Then multiply these two values together. Of course, you still get a long value, but then cut it short, become 3 significant figure. By right, you will be having 0.404. Right, so this is how we get the answer for part A in question number 4. Then let's continue to part B. Using a suitable approximating distribution, find the probability at a total, highlight the keyword of total, a total of fewer than 145 cars and trucks arrive at the fuel station during a randomly chosen 2-hour period. Okay, there are a few important keywords here. The first one is approximating distribution. You are having Poisson originally, right? Then what can you change it? In our syllabus, we can change Poisson become normal. Okay, then we are focusing on total vehicle, and we're also focusing on 2-hour period. All right, so let's have a look for C, car plus truck first. Car plus truck. Car is Poisson, truck is Poisson, car plus truck still Poisson. All right, and what is the lambda for car plus truck? So car for 1 minute is 0.8. Then the truck for 1 minute is 0.4. But that's for 1 minute, right? But we are now interested for 2-hour period. So 2-hour period here basically means you're having 120 minutes. So you have to multiply the lambda with 120. Okay? And next one. When you get the value here, you realize that the value is very large, which is 156. Okay? That's the reason why they ask us to use a suitable approximating distribution. Because when you are having Poisson lambda, when the lambda fulfill the condition that it is greater than 15, then you can basically change it become normal distribution. Poisson is having same mean and also the value for variance. Mean and variance are the same value. Therefore, normal distribution, you're having both also lambda for mean and variance. Okay, then small reminder, because Poisson is discrete random variable, okay, then normal distribution is continuous random variable. And what should you do? You have to apply continuity correction. When you change it, you're having continuity correction. And the continuity correction will be plus and minus or minus 0.5. Depends on the question. Okay, so let's start here. I want to change it become normal distribution. Oh, I shouldn't write as x here. I should write as c plus t. It is normally distributed. Mean is 156. Variance is also 156. And what's the probability that we want to find? They say the total. Total means c plus t. Fewer means less than. It not included the value 145. Fewer ma. Okay, that means 145 does not include that. Therefore, you write the symbol, there's no equal sign. Right. Okay, this is Poisson distributed. When I want to make it become normal, I have to do the continuity correction adjustment. All right. Okay. Then how to do the continuity correction adjustment? You try to draw a few number here, number line. Okay, I'm having 143, 144, 145, and so on. When they say less than 145 in a Poisson distribution, means 145 is not included. So when you calculate the probability, you are starting from 144, then go down 143 and so on. If I try to draw the area or the probability that I want to find, it will be something like this. You can see that the area starts from 144. To make the continuity correction, you need to put a line that is before the area that you want to find. Okay? Or try to cover the area that you want to find. So this value from here, you can see that it's 144.5. And now this is the continuity correction we have, which is 144.5. Okay, yeah. After that, you have already make it into normal distribution, right? To calculate the probability, you have to standardize it. So change it become Z. You're having 144.5 minus the mean 156 divided by standard deviation. Standard deviation also 156. And what's the value of the Z that we get here? We'll get negative 0.921. Okay, so just a reminder again, for the value of Z that you get to find the probability, right, it must be up to 3 decimal places. Okay, then after that, you have to use the normal table to find the probability. Okay, so this area same as 1 minus the probability of Z smaller than 0.921. How to find this particular area? So you have to use the table 0.921. 0.92, this is what we have. Then 1 is a 3. So 8212 plus 3. So you get 8215. Okay, so 1 minus 0.8215. Simplify. Then make it into 3 significant figure. So this is how we solve question number 4. Alright, so we are now at question number 5. Candidate for a certain diploma take 2 tests. The marks for the first test and second test are modeled by independent variables with the distribution, both are normally distributed. Okay, the final mark, F, for each candidate is found by doubling the mark in the first test. Okay, for me, I will want you to highlight and focus on the keyword doubling. So doubling means that you multiply the first test with 2, which means that later, if you want to calculate the variance, you have to square the 2. Doubling, that means times 2, right? Okay, then and adding the result to the mark in the second test. Add the result in the mark in the second test, right? After that, they want you to find the probability that the mean for the final mark at random sample of 25 candidates is greater than 143. Then the mean of the final mark is also the keyword for us to set up the question. Okay, this is basically a question about the sample mean, right? Because the mean of final marks. But before that, we need to know how to find out the mean and also variance for final mark first. Okay, so how to get the final mark? Yeah, so final mark is equals to, maybe the first test I put it as x, so I'm having 2x. The second test is a y, so 2x plus y. If I want to get the expected value or the mean of the final mark, you will be having 2 times of expected value of x plus the expected value of y, or mean of x and mean of y. Okay, then when you try to put in the value, you have 2 times of 38.1. The mean of y is 64, right? Okay, then what do you get from here? You'll get 140.2. This is the mean for the final mark. And next, I want to find the variance of the final mark. So when you want to take out the 2 from the variance, right, it is a multiplication, doubling. Doubling means you multiply. Multiply 2 with the first test mark. And to calculate the variance, when you want to take out the 2 from variance, it is multiplication. Therefore, you have to square the 2. So you're having 2 squared with the variance of the x. Then plus the variance of y. What's the variance of x here? It will be 3.8 squared. And the variance of the y will be 6.1 squared. Then you try to add them together. By right, you'll be having 96.97. Okay, so this is the mean for the final mark, and this is the variance for the final mark. But for now, we are looking for the sample mean. Okay, the mean marks. To calculate the min marks for 25 candidates, you might need to know what is the distribution for the sample mean. Okay, my original population final mark, the final mark means population. So the original distribution for the final mark is normally distributed. Therefore, the sample mean is also normally distributed. Okay. All right. Then after that, what is the mean for the sample mean? It will be the same as the population mean. Same as population mean. What is the variance for the sample mean? So the variance of the sample mean will be this one, but you have to divide it by the sample size. So divided by sample size means divided by 25. And from here, by right, you'll be getting a number 3.7988. Okay? Alright, then after that, let us start to calculate the probability. I want to know the sample marks, min marks, greater than 143. So greater means more than 143. This is normally distributed. To calculate the probability, you have to change it become Z. So I'm taking 143 minus the mean divided by standard deviation. So the standard deviation here is square root of 3.7988. Okay, maybe for some students, they might ask, what you learned before is like you have to divide by sigma over square root n, right? Just for your information, the square root 3.7988 is already the sigma over square root n. Because how I get the 3.798, yeah, I'm getting the population variance divided by sample size, right? This is sigma squared over n, and you get this value. When you take square root of 3.7988, that means you are having the sigma over square root n. Okay? If you don't want to use the 3.7988 like this, just like what I did, then you can just take square root of 94.97 divided by square root of 25 is the same. Right? I just tried to calculate the sample variance earlier. Okay? Right. Then now let's continue further. What's the value of Z that I have here? I get 3 decimal places. Answer is 1.437. Okay? Then to get the area, I have to take 1 minus Z smaller than 1.437. So where's the 1.437 here? 1.43 is this one. Then 7 is this 10. That means you have to take 9236 plus 10. And you should be having 9246, right? Okay. Then 1 minus 0.9246. Again, the final answer would be 0.0754. Right, so this is how we solve question number 5. Question number 6. It is claimed that 28% of the voters in a certain town support the political party. There's a researcher suspects that the true figure is less than 28%. Highlight the keyword less than. It will be a keyword to help you set up the alternative hypothesis later for less than. Okay, she interviewed a random sample of 30 voters from the town, and she finds that the 4 voters in the sample says they support the party. The 4 voters here, the value 4 is the observed value. We will use it to calculate the p-value later when we want to carry out the test. She plans to carry out a hypothesis test at 10% significance level. Use a binomial, highlight the keyword binomial, distribution to carry out the test. Right, so when you want to carry out the test, the first step is please set up the null and also alternative hypothesis first. We are talking about the support rate. So originally, they said support rate should be 28%. So I will put it as a proportion, 0.28. And for the alternative hypothesis, the keyword less than. So we are having the probability or proportion less than 0.28. And this is basically the researchers' suspects, right? Okay, then after that, how are we going to carry out the test? We have to use p-value for a binomial distribution. So let's try out the distribution first. We are having x is binomial distributed. I'm having 30 voters. And after that, the support rate is 0.28. Then to calculate the p-value to carry out the test, I need the observed value. The observed value means the value that you get or the value that you observe when you try to run the test or maybe carry out a survey when you run the test, right? So for this one, 4 voters, the fault will be our observed value. And then because of the alternative hypothesis is having smaller than, therefore, to calculate the p-value, we will be having x smaller equals to the 4. So please take note that every time when you want to calculate the p-value, right, the value 4, the observed value usually will be included because they said 4 voters in the sample say they support. So the 4 is already included in the observed value. So they usually will be having the equal sign here. Right, then now let's start the calculation part. It is a binomial distribution. So x smaller equals to 4. That means I have to start with x equals to 0, x equals to 1, x equals to 2, x equals to 3, x equals to 4. So I'm having 30C0, then 0.28 power 0, 0.72 power 30. Then plus 30C1, 0.28 power 1, 0.72 power 29. Then x equals to 2. All these are the binomial distribution formula, okay? X equals to 3. Then x equals to 4. So I need to include up to 4. Okay, I cannot have 5 because they said x smaller equals to 4. Right, then after that you try to press calculator. By right, you'll be having 0.0495. And this is the p-value that we get for the test, right? Okay, so next step we have to make a decision. But before that, we need to compare our value, yeah? P-value is 0.0495. Okay, and then it is actually smaller than alpha, which is 0.10. If I try to visualize it using a not correct graph or diagram, binomial, right? So I'm having the value of the x start from 0 until 30. And then I know that my rejection region on the left and the area for this rejection region is 0.10. Then just now when we calculate the probability of x smaller equals to 4, the area that I get is smaller than the alpha. So that means if I try to draw the box, 4 will be somewhere inside the rejection region because the probability that I count for x smaller equals to 4, this purple color area is 0.0495, where it should be smaller than the green color area, which is 0.10. So 4 falls under the rejection region. So from here, I know that basically I have to reject the null hypothesis. Okay, so a reminder, yeah, this graph cannot be shown in the exam because it is not the correct graph. But it is a helpful graph to help you to visualize what do you have here. Okay, right. So this is reject null hypothesis. Then please make a statement that is related to the context of the question about your decision. So you reject the null hypothesis means that there is sufficient evidence to show the researcher's suspect is true, right? So there's sufficient evidence to show that the support rate for the party is less than 0.28. Okay, alright, so this is how we carry out the test. These are a few steps that you need to make sure that you show them in your calculation, in your solution. Alright, okay, then let's have a look for part number B. For part B, now they ask you to state with a reason whether it is possible that type 1 error was made in carrying out the test. Okay, so first of all, you must know what's the definition for type 1 error. Type 1 error means that you reject the null hypothesis when the null hypothesis is true. Okay, in the test that we carried out just now, our decision is reject the null hypothesis, right? So when you reject the null hypothesis, it means that it is possible for you to make a type 1 error, right? So you should tell them that yes, it might be possible for you to make a type 1 error because in your test, you reject the null hypothesis. Okay, if your decision is accept the null hypothesis, basically it is impossible for you to make a type 1 error, because type 1 error means that you reject the null hypothesis. Okay, yeah, so this is how we answer that part B here. After that, they want you to do something else, right? Okay, part C. There's still part C here. Okay, later the researcher carry out a similar test at 10% significance level also, using a new random sample of 30 voters from the town. Find the probability of type 1 error. Okay, so now I'm still having the same distribution, yeah? 30, and the support rate is 0.28. Alright, to calculate the probability of type 1 error, like what I told you just now, the definition is reject the null hypothesis when the null hypothesis is true. Okay, when you want to do the calculation, right, what should I put for the reject null hypothesis? Basically, have to substitute in the rejection region. Okay, when the null hypothesis is true. And now here come the problem, because we actually don't know what is the rejection region for the test, right? Okay, then let us recall back the test in part A just now. Do you still remember this diagram? Okay, x is having from 0 until 30. My rejection region is here, where the significance level is 0.10. That means my rejection region is this big. Okay, then just now in first part, right, part A, when I carry out the test, I know that the 4 still falls under the rejection region. Okay, then now I want to figure out 5. The next value for x is a 5, right? I want to know 5. If I try to calculate the 5, will the 5 falls under rejection region, or will the 5 fall under the acceptance region? Okay, therefore I need to carry out this calculation first. Then what I do is I try to find out the probability of x smaller equals to 5. The probability for x smaller equals to 4 is 0.0495 from part A. So again, this is the value that I get from part A. If you keep the long value, then that will be the best. Usually I will keep the long value. Okay, you use the long value here. This is x smaller equals to 4. Then you have to add x equals to 5, which is 30C5, 0.28 power 5, 0.72 power 25. And what's the value that you get from here? You get 0.116. And if you try to compare it with the alpha, it is more than 0.10. Okay, so what does it mean here? It means that if you want to draw 5 and also the area for the 5, x smaller equals to 5, it will be actually this bigger area, the blue color area, which is bigger than 0.10, because 0.116 is bigger, right? So when you try to draw the 5 must be in the acceptance region already. Okay, and from here you can see from this diagram, what are the number of the x falls under rejection region? So you have 0, 1, 2, 3, and 4. 5, 6, 7, 8, 9, 10 until 30, all of them are under the acceptance region. Understand what I say or not? Alright, so you need to have the calculation for this part first to check and see whether your 5 belongs to rejection or 5 belongs to acceptance. And now I know my rejection region is x smaller equals to 4. Therefore, I have x smaller equals to 4, given that the p is equals to 0.28. To calculate the probability for x smaller equals to 4, you start from x equals to 0, x equals to 1, x equals to 2, x equals to 3, x equals to 4. And you realize that you already calculated the value just now in part 1. Alright, correct or not? X equals to 0, x equals to 1, x equals to 2, x equals to 3, and x equals to 4. And your answer for the type 1 error should be 0.0495. You don't need to repeat the calculation anymore. You can just directly write out your answer from first part, and it is equals to 0.0495. Okay, so this is how we answer question number 7. There's a firm makes a certain type of battery powered toy. The battery life is denoted by X hours. So they are measuring in X hours, in hours. The population mean of X is supposed to be 12. the quality control department wish to test whether the population mean is actually less than 12. Highlight the keyword less than. So I think you should know, right? This keyword again, it will be the keyword for you to set up alternative hypothesis later. They test a random sample of 50 of the toys and also find the sample mean was 11.4. So first step, they want you to state the null and also alternative hypothesis. We are testing the population mean. Therefore, the null hypothesis is mu equals to 12 hours. And how about the alternative hypothesis? It should be, because of the keyword less than, yeah, okay, then the mu should be less than 12 hours. I think this is easy, right? Okay, then let's continue to part B. You may assume that the standard deviation of the battery life is 2.3 hours. Okay, this is a population standard deviation. Show that the value of 11.4 leads to rejection of the null hypothesis at the 5% significance level. So basically, this is what they want to do is that they just want you to continue to carry out the test. You have set out the null and also the alternative hypothesis. Then let's have a look for the remaining of the test. Okay, it is a normal distributed question, right? Oh, they didn't mention that the population is normal, but since the sample size is large, therefore by using central limit theorem, we can assume that it is a normal distributed. Right, then after that, let's have a look for this one. We are having alternative hypothesis mu less than 12. Therefore, I know that my rejection region on the left. And how big is the area of the rejection region? It is a significance level 5%, so 0.05, and this will be 0.95. Okay, so you can use either critical value approach or p-value approach to find out the answer, to carry out the test. For me, usually for normal distribution, I will use critical value. Alright, so let us find out the critical value first. What's the value of the Z? What's the critical value in this test? Looking for 0.95. Okay, so please look for 0.95. The Z will be 1.645. Okay, so negative 1.645. Because of, you can see very clearly that the mean of the normal distribution is a 0, right? For standard normal is a 0. So the critical value is before the 0. Therefore, it should be a negative value, which is negative 1.645. After that, I have to find the test statistic. So to calculate the test statistic, what is the formula here? The formula is mean minus the population mean divided by standard deviation over square root n. What is the sample mean? They have already tell you that it is 11.4. What is the population mean? It is 12. What's the standard deviation? 2.3. What is the sample size? Square root 50. And from here, you'll get the value negative 1.845. Sorry, 1.845. And this will be your test statistic. Then we write out the statement, the test statistic. Test statistic is negative 1.845 less than critical value negative 1.645. And if you try to put this test statistic in the diagram that I draw, you will see that negative 1.845 will fall under the rejection region because negative 1.845 is smaller than negative 1.645, right? Therefore, when you want to draw in the diagram, it should be before the negative 1.645. And this green color line actually falls under the rejection region. Therefore, from here, we know that we have to reject the null hypothesis. Okay? Yeah, so you have to show them the detail how you carry out the test, although they have already give you the result. Okay, but you need to show that the result is actually reject null hypothesis. Then let's have a look for question number C. It is given that this sample mean leads to rejection of the null hypothesis at the alpha significance level. Find the set of possible values of alpha. To find the alpha, we need to use back the diagram again. Okay, so now they said it is given that the value x equals to 11.4 leads to the rejection of the null hypothesis. Okay, so x equals to 11.4. If you try to calculate the test statistic, it will give you the test statistic value equals to negative 1.845, right? This is from the previous part in part B. Okay, and now they said I want to make sure that this mean value or this test statistics is always lead to the rejection of the null hypothesis. That means I need to know first, if let's say my value of the z here is negative 1.845. Forget the negative. Okay, negative 1.845. Then what's the area here? Let me find out first, okay? So I try to find out the probability of z smaller than negative 1.845 first. It will be 1 minus the probability of z smaller than 1.845. Then you can get the value from the table, right? So looking for 1.845. 1.84 is this one. 5 is the 4. So 9671 plus 4, you get 9675. So 1 minus 0.9675. Then you get 0.0325. Okay, so this area, you get 0.0325. Then how can I make sure that the z equals to negative 1.845 always is falls under the rejection region? If you want to make sure that the z, okay, always falls under the rejection region, that means the significance level must be always bigger than the area for the z smaller than 1.845, right? Okay, therefore your alpha must be bigger than 0.0325. Therefore your alpha should be greater than 3.25%. They say alpha percent, so I will write alpha equals to greater than 3.25. Because only when your sigma plus your alpha is greater than this area, then only we will make sure that the z always falls under the rejection region. Okay, so this is how we get the answer for 7C. So then negative 1.845, just an extra explanation to make sure that you understand why the alpha comes, how the value comes, falls under the rejection region. Okay, so this is how we solve question number. Okay, so the very last question for this paper, I'm having the diagram shows a probability density function. It is a triangle from here between x equals to 0 to x equals to a. The graph consists of a straight line through O with a gradient k, where k and a are positive constants. So highlight the keyword positive constant. Elsewhere, fx equals to 0. It is given that the median of x is set to find the value of the k. Right, so first of all, we need to know what is the equation that we have here first. Okay, what's the function of fx? So like what we learned earlier, it is a straight line, right? Straight line. So the general formula is mx plus c, where m is a gradient. Then for this question, they already tell you that the gradient is a k. So you're having kx plus c. C is the y-intercept. Do you see any y-intercept here? You can see that it intercepts at 0. So eventually your function is kx. Okay, when you are having the function kx, then from here you're able to use it to find out the median. Okay, so we want to the question gives us the median equals to SET2, right? So let's try to figure it out here. Median is equals to SET2. What does it mean? It means that when you try to integrate from the minimum value until the median for this particular function, you'll get the probability is half. Because from 0 to median, it will cover 50% of the function, right, of the whole data. Okay, so you can have 0 to sub2 kx equals to half. Alright, then you can start the integration. K is a constant, I usually prefer to take it out. Then I'm having x squared over 2. Then want to substitute in the limit for sub2 and 0. Okay, I still prefer to take out the constant. Substitute sub2 into the x. Then you realize that, oh, sub2 and 2 can be simplified, right? Sub2 square and 2 can be simplified. And very easily you will get your value of the k, which is equals to half. Okay, yeah, so this is the method to find the value of k lah. Then after that, for part number B, they want you to find the value of expected value of the x. Okay, to get the expected value of x, what you need to have here is you need to substitute the k into the equation. Your k into the equation. Okay, then maybe here you need to try and figure out what's the value for a first. If not, you'll have your final answer in terms of a, right? Okay, so you need to know the value for a first. How to find the value of a? We know that the total area under the graph is a 1. Okay, so the whole area, purple color area here is a 1. And since it is a triangle, so I prefer to use the basic triangle area formula. So the base is the a. What's the height here? Because we know that it is half x, right? When x equals to a, then the height here will be half a. Alright, so you know that half times base times height equals to 1. So the area of the triangle is equals to 1 for a continuous random variable, right? So let's find out the a first, yeah? So I try to write out in this way. The area of the triangle is equals to 1. So half times base is a. Then height is half a equals to 1. So you're having a square equals to 4 and a should be equals to 2. A should be taking for a positive value, so a should be equals to 2 only, right? Then now only you can find out the expected value of the x. To find out the expected value of x, you need to integrate from minimum value to the maximum value that the x is defined. So you are having 0 until 2, 0 to a, right? So 0 until 2. To get the expected value, you have to multiply the x with the function first. So your function is half x before you start the integration. Okay, then I think this is an easy integration. X squared, integrate, you will be having x power 3 divided by 3. Then substitute in the limit 2 and also 0. Okay, my personal habit is I prefer to take out all the constant first. Only I substitute in the limit, so I'm having 2 power 3 minus 0 power 3. Then 2 power 3, I'll get an 8. So 8 over 4. Oh, sorry, 8 over 6. Then after you simplify, you'll be having 4 over 3. This is the expected value of x for this part. Okay, yeah, so this is the end of the video. Alright, and thank you very much for watching the video.